Representations of graph. A graph is a nonlinear data structure consisting of vertices and edges. The vertices are sometimes referred to as nodes and the edges are lines or arcs that connect any two nodes in the graph. Here are two most common ways to represent a graph: adjacency matrix and adjacency list. Let's see adjacency matrix in detail. An adjacency matrix is a way of representing a graph as a matrix of Boolean zeros and ones. Let's assume there are n vertices in the graph. So, create a 2D matrix, adjacency matrix n by n, having dimension n into n. If there is an edge from vertex I to j, mark adjacency matrix I by j as 1. If there is no edge from vertex I to j, mark adjacency matrix I by j as 0. Representation of undirected graph to adjacency matrix. Here, the figure shows an undirected graph. Initially, the entire matrix is initialized to 0. If there is an edge from source to destination, insert 1 to both cases. That is adjacency matrix of destination. Representation of directed graph to adjacency matrix. This figure shows a directed graph. Initially, the entire matrix is initialized to 0. If there is an edge from source to destination, insert 1 for that particular adjacency matrix destination. Let's see adjacency list. An array of list is used to store edges between two vertices. The size of array is equal to the number of vertices, that is n. Each index in this array represents a specific vertex in the graph. So, the entry at the index I of the array contains a linked list containing the vertices that are adjacent to vertex I. Let's assume there are n vertices in the graph. So, create an array of list of size n as adjacency list of n. The adjacency list of 0 will have all the nodes which are connected, that is neighbor to vertex 0. Next, the adjacency list of 1 will have all the nodes which are connected to vertex 1 and so on. Representation of undirected graph to adjacency list. The figure undirected graph has 3 vertices, so an array of list will be created of size 3 where each indices represent the vertices. Now vertex 0 has 2 neighbors, that is 1 and 2. So insert vertex 1 and 2 at indices 0 of array. Similarly, for vertex 1, it has 2 neighbors, that is 2 and 0. So, insert vertices 2 and 0 at indices 1 of array. Similarly, for vertex 2, insert its neighbors in array of list. Next, representation of directed graph to adjacency list. The figure shows the directed graph has 3 vertices. So, an array of list will be created of size 3 where each indices represent the vertices. Now, vertex 0 has no neighbors. For vertex 1, it has 2 neighbors, that is 0 and 2. So, insert vertices 0 and 2 at indices 1 of array. Similarly, for vertex 2, insert its neighbors in the array of list.